Good morning, everyone. My name is Shivan Reddy, and um, along with Neha Reddy and Ritik, we have done our project on optimization of organic acid for intimate care applications by RSM. And these are the content. Coming to the aim, our aim is to optimize the organic acid for intimate care applications by RSM. And objectives are to prepare various samples containing different compositions of organic acid according to the RSM table and to find out the response of R1, R2, R3 for antibacterial, antioxidant, and hemocompatibility, and also for optimize the significant parameters, reduce the influencing parameters and concentration from the ANOVA table. And our novelty is to the best of our knowledge, no one has optimized the antibacterial, antifungal, and biocompatibility properties of organic acids, which are succinic acid, malic acid, citric acid, and ascorbic acid. And optimization for intimate care applications is being done by us using different compositions of this organic acid. And also, we want to find out the synergetic effect of different compositions of organic acid for antibacterial, antioxidant, and hemocompatibility. And coming to the introduction, lotions and creams have many toxic chemicals. These chemicals have many effects on the body and which are used on day-to-day basis, which furthers the damage. Organic acids taken into account are malic acid, succinic acid, ascorbic acid, and citric acid. Using these organic acids has many benefits, like it fights bacteria and inflammation, it improves skin's barrier function, and many more in the natural way. There is a safe range, which is minimum and maximum range of the organic acid. Citric acid has 2 to 5% range. Succinic acid has 2 to 5% range. And ascorbic acid has 1 to 20% range. Malic acid has 2 to 5% range. RSM. RSM is the response surface methodology. It's like a tool that helps us to figure out the best way to mix things to get the best result. It is often preferred because it's faster and requires fewer resources compared to simpler methods. And it is also a useful approach for improving how we prepare samples. Um, we did our literature review on the 4 acids. So coming to the malic acid, it is often referred to as apple acid. And its functional skin properties, it has the functional skin properties of cocoa pod extracts have, which has antioxidant components. And malic acid is a common ingredient in skincare products. And this is the structure of malic acid. Succinic acid was often referred to as amber acid because it is present in amber, a fossilized resin. Its role as an intermediate in various chemical processes makes it a platform chemical, serving as a precursor for the production of numerous specialty chemicals. And this is the structure of succinic acid. Citric acid finds use in a variety of industries, including food, medicine, cosmetics, chemicals, and flavoring. It helps in adding a nice scent. And also it is used in oral care like mouthwash and also used to improve the taste of pharmaceuticals such as syrups, solutions, etc. Some can even be used in cosmetics to fight bacteria or as pesticides. And this is the structure of citric acid. Ascorbic acid is a vital micronutrient for humans. It plays a numerous biological role and it serves as a potent antioxidant by directly neutralizing reactive oxygen species. And also, vitamin C presence in ascorbic acid is very popular for its antioxidant properties. And this is the structure of ascorbic acid. Coming to the flowchart of our work, first is we need to find out the minimum and maximum ranges of the concentration to find to feed into the RSM software, and then it should be generated or generate the test run from the RSM software. And after that, we need to weigh different quantities of organic acid. And after weighing it, we need to mix the compositions with 100 ml of water to form a homogeneous mixture. And we need to find out the response of R1, R2, and Rg for antibacterial, antioxidant, and hemocompatibility. And we need to optimize the parameters to reduce the influencing parameters and concentration from the anuvatic.
So myself, Ritik. So coming to the materials, these are the materials required, and there are three different methods. One is agar well diffusion method, one is DPPH method, and another one is anti emo compatibility method. So coming to the work progress, so primarily we found the minimum and maximum ranges of the concentrations that we fed into the RSM software. Then after the RSM software generated the test run of 30 samples in the given table. CS stands for citric acid, MS stands for malic acid, and SS stands for succinic acid, and AA stands for ascorbic acid. So R1, R2, R3 are the various responses, that is antioxidant and antimicrobial and hemocompatibility. So the concentration in the above mentioned table is gram per 100 ml. So we weigh different quantities of organic acid. Then we mix the composition with 100 ml of water to form a homogeneous mixture. So these are 30 different samples as per the given table one that we stored in the plastic containers. So coming to the first test, that is antimicrobial test. So in this test, we took 12 nutrient agar plates were prepared, and five wells were punctured with a gel puncture. Then the 6 agar plates were spread with E. coli and 6 others spread with S. aureus. All the 30 samples were added to the labeled holes containing both the bacteria. Then these agar plates were incubated overnight at 37 degrees Celsius. Then the results were observed. So these are the uh, samples that we spread with E. coli and S. aureus, and we added the samples accordingly to the each of the whole labeled above. So coming to the antioxidant assay, this is the second response, R2 response. In this, we took 80 mg of DPPH that is added to 200 ml of methanol. Then after, ascorbic acid solution is made by adding 10 mg of ascorbic acid into 10 ml of distilled water. Then 4 ml of DPPH and methanol solution is taken as negative control. Then 4 ml of DPPH and methanol solution that is added to 200 microliters of ascorbic acid solution that is taken as positive control. For samples, 200 microliters amount of sample is added to 4 ml of DPPH and methanol solution. Then the test tubes were then kept in dark conditions for an hour before checking an OD. OD is measured at 517 nanometers with methanol as blank. With the help of the resulting OD values, antioxidant activity was calculated using this formula. For calculating antioxidant activity, we use this formula. So these are the different samples mentioned in the figure 7. So this is the wavelength mentioning 517 nanometers in figure 9 that we use for checking OD. So coming to the R3 response, that is hemocompatibility, in which we mixed 5 ml of saline to 4 ml of goat blood in falcon tube. Then after, we added 0.5 ml of this solution to 32 Eppendorf tubes. Then we added 100 microliters of 30 samples into the labeled Eppendorf tube. Then the additional 2 Eppendorf tubes are labeled as positive and negative control. In the negative control, we added 100 microliters of 0.1 normality HCl to the saline goat blood mixture. And for the positive control, we added 100 microliters of saline to the saline goat blood mixture. These Eppendorf tubes were then centrifuged at 3000 RPM for 10 minutes. Then the supernatant is then collected and the OD values are checked at 545 nanometers using the spectrophotometer. Then the blank for checking the OD, we used saline for checking blank as OD, and this is the formula for checking hemolysis percentage.
Now coming to the results, antimicrobial test results. So starting with these figures, we can see the zone of inhibitions for all the samples that we have added with respect to E. coli and Esophagus. Now we haven't gotten two samples results, the 20th sample that we used with E. coli and the 22nd sample that we used with Esophagus. This is the figure that consists of the zone of inhibitions with the agar plates that were spread with Esophagus. Here in this table, we actually calculated the dimensions of zone of inhibitions horizontally, vertically, and diagonally in millimeters. And then we calculated the mean plus or minus standard deviation values. Here the highlighted values show very good values and which can be used in any kind of intimate care applications. Now coming to antioxidant assay. So as soon as we add DPPH and methanol solution to the samples which show positive results have changed their color from purple to yellow, whereas the ones which did not change their color show negative results. Here we can see from the figures itself that the samples that have shown yellow as well as purple. Now we check the OD of all these samples at 517 nanometers, and then we calculated the antioxidant activity in percentage, which was shown by the formula given below. We again did the experiment for antimicrobial test results for getting the before samples result. These were the two samples for the results that we could not get before. And we again calculated the dimensions of the zone of inhibitions. And again, the highlighted values are the ones which show good antimicrobial properties. Now coming to hemocompatibility assay, we optimized few of the solutions from the above tests that are 18, 15, 27, and 30. And then we did the hemocompatibility test for only 4 of these samples, along with positive and negative control. We then checked the OD at 545 nanometers, and then we calculated hemolysis as well as hemocompatibility as per the formula which was shown before in the earlier slides. Now for positive control, we got 0.134, and for negative control, we got 0.1.
So this is the RSM software. In the RSM software, we use StatEase 360 application for checking the antimicrobial test for E. coli. In this, we took there were various fit summaries such as linear, cuboid, cubic, quadratic, and quartic. In which we took cubic model. So these are the different combinations of acids. This is in which A is labeled as citric acid, B is labeled as malic acid, C is labeled as succinic acid, and D is labeled as ascorbic acid. These are the various combinations of model that showed p-value less than 0.01. AB is the combination of citric and malic acid. CD is the combination of succinic and ascorbic acid. Like that, these were the combinations of different acids from the StatEase software. So this is the graph predicting the actual values and showing the actual and predicted values that the data we loaded in the software. So it signifies that the points present on the straight line, they showed the good composition. They are the solutions were all on the straight line on the graph. So here it comes. A is the citric acid, B is the malic acid. This is for the E. coli. So in this, the red dot signifies the optimized concentration of solution. This optimized concentration of solution that we can use in the use for our research. So coming to the conclusion, the use of natural products in intimate care application is very important as we use them in the daily basis. Organic acids are natural and safe. They're cost effective and environmental friendly. Organic acids are the best option for organic acids such as succinic acid, malic acid, citric acid, and ascorbic acid were taken into the consideration. The response surface methodology is a valuable and statistical and mathematical approach used in various fields. RSM is like a tool that helps us to figure out the best way to mix things to get the best results. RSM is often preferred because it is faster and requires fewer resources compared to other methods. Using this RSM method, we can obtain the optimized solution by varying compositions of acids. This optimized solution is the best among all and can be used in lotions, creams, and hydrogels, and also for wound healing. In summary, it is advantageous to use organic acids in intimate care applications. Thank you.